Let's apply the ratio test to the series. The sum from n equals 1 to infinity of open 3 to the power n minus 2 to the power n close open x plus 2 close to the power 2 n over n plus 4. Let a sub n equal open 3 to the power n minus 2 to the power n close open x plus 2 close to the power 2n over n to the power 4. Step 1, ratio of successive terms. We compute the absolute value of a sub n plus 1 over a sub n equals the absolute value of open 3 to the power n plus 1 minus 2 to the power n plus 1 close open x plus 2 close to the power 2 open n plus 1 close over open n plus 1 close to the fourth power times n to the fourth power over open 3 to the power n minus 2 to the power n close open x plus 2 close to the power 2 plus to the power 2n. We simplify, and that equals the absolute value of 3 to the power n plus 1 minus 2 to the power n plus 1 over 3 to the power n minus 2 to the power n times open x plus 2 close squared over open, and for the numerator open n plus 1 close to the fourth power over n to the fourth power close. Let's break this into parts. Analyze each part. Exponential part, 3 to the power n plus 1 minus 2 to the power n plus 1 over 3 to the power n minus 2 to the power n equals 3 times 3 to the power n minus 2 times 2 to the power n over 3 to the power n minus 2 to the power n equals 3 minus 2 times open 3, restarting that, 3 minus 2 times open 2 over 3 close to the power n over 1 minus open 2 over 3 close to the power n approaches 3 as n approaches infinity. Polynomial part, open n over n plus 1 close to the fourth power approaches 1 as n approaches infinity. The power of x part, open x plus 2 close to the power 2. So the whole ratio tends towards the limit as n approaches infinity. The absolute value of a sub n plus 1 over a sub n equals 3, the absolute value of x plus 2 to the power 2. Step 3, apply the ratio test. If the limit the absolute value of a sub n plus 1 over a sub n is less than 1, the series converges. If it's greater than 1, the series diverges. If it equals 1, then it is inconclusive. So 3 times the absolute value of x plus 2 to the power 2 is less than 1, and that yields the absolute value of x plus 2 to the power 2 is less than 1/3, and therefore the absolute value of x plus 2 is less than 1 over 1/3. Thus the radius of convergence is 1 over the square root of 3. I think I pronounced that top line wrong. The last part is the absolute value of x plus 2 is less than 1 over the square root of 3. And thus the radius of convergence is 1 over the square root of 3. And the interval of convergence is x is an element of open negative 2 minus 1 over the square root of 3 and negative 2 plus 1 over the square root of 3. We fully determine convergence. Again, we check endpoints separately. Conclusion: using the ratio test, we get the same condition. X is an element of open -2 minus 1 over the square root of 3, and -2 plus 1 over the square root of 3 close. The ratio test confirms the radius of convergence. Endpoint convergence still needs to be analyzed separately, but yes, the ratio test works well and gives the same core result.